Welcome. We're going to look at acids and bases and their involvement with CO2 in seawater, all part of ocean acidification. So distilled water has a pH of 7. But why? Some of the water molecules dissociate, break apart into ions, and become charged particles, but a very small amount. When water dissociates, it forms equal amounts because for every one of these, we get one of those and one of those. This concentration is extremely small. You might remember from math, 1 times 10 to the negative 7th. What would that be, like 10 billionth, 10 millionth, because a million is to the 6th. So 10 millionth of a mole, a very, very small amount. Now, when we think of acids and bases, there's many different definitions of acids and bases out there, but we're going to go with the most general, simplistic idea. So something is an acid when there is more hydrogen ion in the solution than hydroxide. Neutral is when they're equal. So that can only be one possibility. And something is basic when there's more hydroxide ion than hydrogen ion. When we have the pH scale, when we have a lower pH, those are the acids, as you might notice some of these things saying acid on them, while more alkaline, another term for basic, is more things towards the higher end of the scale. Taking a little deeper look, one of the misconceptions is that all things form either hydrogen or hydroxide ions. It's not true. There are many exceptions. Hydrochloric acid, one we used in our last lab we did in class with the magnesium. When you put it in water, it makes hydronium and chloride. And this hydronium is often we think of water with an H+. So HCl really breaks into hydrogen ion and chloride. This works with the H2O to produce H3O+. These are chemicals that produce hydrogen ions in aqueous solutions. Bases, very similar. So NaOH is sodium hydroxide. These will separate or dissociate. As you can see, the water is still water. It doesn't combine like the hydrogen ion does. It'll produce just sodium ion and hydroxide ion. So these that produce hydroxide ions when in aqueous solutions. Those will be our basic, pun intended, I guess, definitions of bases. Well, utilizing these two definitions of a base and an acid, if we were to look at vinegar, considering what it's at, we see that there's a OH, or there's also maybe just an H there. So is vinegar an acid or a base? Well, based looking at what the products would be, you hopefully should determine that it would be an acid because of the fact that it produced hydrogen ions when put in water, when it dissociated. So let's put this together in the concept of ocean acidification. So the first thing is CO2 enters the ocean. So that means it goes from CO2 as a gas, and we're going to use our equilibrium arrows because it both goes from a gas to being dissolved and from being dissolved to being a gas. To CO2 aqueous, meaning dissolved in water. So this is the first step of getting into the ocean. The ocean can't be acidified if there's no CO2 in it. So this is how we get into the ocean. Next, we have this ocean water react with the aqueous CO2. And these are also equilibrium reactions to make carbonic acid, H2CO3. So now we have produced this H2CO3 by combining the CO2 that's present and water. Keep in mind, this would occur naturally because of the fact fish, they're respirating, they're breathing. They're also breathing out CO2, but it's aqueous because it's within the water. So carbonic acid is also always being made by organisms that are respirating the oxygen present in the water. Lastly, we have our carbonic acid. Again, equilibrium's at play, which when this is put into water or is in water is going to dissociate, making our different ions here. So we can see that due to the fact of this H2CO3 breaking apart, it's going to produce more hydrogen ions. And these hydrogen ions can then react with other types of shellfish and other creatures to where now those are going to start making other side reactions and causing a problem with the acidification of the ocean. So this is the beginning of those issues that we are increasing the amount of hydrogen ion in solution by the CO2 coming in, making the carbonic acid, then making this bicarbonate ion and the hydrogen. And this plays a big role in breaking down a lot of the sea creatures in the ocean.